Hello everyone. So today we are going to solve 23rd of August problem that is from Geeks for Geeks, that is Geek in a maze. What this problem is saying is we have given a maze mat of size n cross m, and there can be two possible values in that particular array, 2D array. One is dot, one is the this obstacle that is representing there with the hashtag. So we need to find out this representing an obstacle and this representing an empty cell. And we have given some variables, more variables like R and C that is giving us the starting point. 1 comma 0 is the starting point. U and D that is representing how many cells we can go up and how many cells we can go down. There is no boundation on the left or right moves. There is a boundation on up and down. So at most you can move one, at most you can move down the one move, and you have to find the how many distinct empty cells that you are visiting with this particular configuration. So there is one more boundation. If the starting cell is itself is obstacle, then it means we cannot move anywhere. Then we have to return zero, and you can move only in the four directions: up, down, left, and right. Okay. So let's see on the whiteboard. Guys, first of all, I will try to solve this problem with with two approaches. So please with me, this is a not an easy problem. Like there is a multiple edge cases in this. I will try to be covered up as much as possible. Okay. So consider this is the configuration we have given, and I will quickly create the matrix that we have given. So this is also the and this is okay. This this one, this. First, we will show basic example. What it is saying is this is 0, 1, 2. This is 0, this is 1, this is 2. And we have given the initial cell as 1, 0. So it means this is the initial cell 1, 0. And we can move upward 1 and downward as the D moves. Okay. So first of all, first thing is this is not related to this problem, but you have to understood this thing. Like if you are at I comma j, any cell you are, what are the possible configuration at the four directions? Like upward, if you go, the row will be decremented, but the column will be same, remains same, right? If you go downward, the row count will be incremented, but the column will remain same. If you go right, it means your row count will be same, but your row number will be same, but your column number will be incremented by one. And if you go left, so it means your row number will be same, but your column number will be decremented. So it means I minus 1j, I plus 1j, ij minus 1, and ij plus 1. So if you are at this, okay, so consider we have some data structure we will store here. Like initially we are at the 1 0, okay, and 1 0. And consider we have not took any upward moves or downward moves initially. Okay, so this will store at this. So this is row, column, and how many upward moves we have to, how many downward moves we have to. Okay, so guys, I'm still like if you are, please be with me till the end of the video. You will understood very much of the important approach. This approach will not going to be work just thrill it is, but I will try to approach why this is not gonna work. Okay, this is a very important part of this problem. So row column up and down. Okay, so we have given this. So where we can go? Can we go upward? We can go. Okay, so we will store this variable. So this will be 0, 0. But we are going to take one upward. Okay, and that is allowing one up. One we can go. So one we can go and 0, and we will remove this and consider we are marking this cell as a visited array. Okay, and we have some visited array also. Consider this thing and we are marking this as visited as true. And now we are moving in the upward direction. Can we move downward? No, we cannot move downward. Why? Because this is an obstacle and obstacle cell we will not going to cover. Can we move right? No. Can we move left? No. So it means this is the only possible configuration we can move. And this is the visited cell. So now this 0, comma 0, from where 0, comma 0 we can go. Now we are at here. Can we go right? Yes, we can go right. Okay. So it means 0, comma 1. And are we taking any upward or downward move? No. So we will replicate the existing one, 1 and 0. Okay. Can we move down? No, we cannot go right because this is the already visited cell. If we go down, then it means down to up, up and down. So this will be going to the stack overflow. So there is no point to go to the visited cell. Okay. We will not go to this. Can we move left? Can we move up? No, we cannot move. So this is the only configuration. So it means we have visited this cell also. Now to come to this point, okay, now we are here 0, comma 1. Can we move right? Yes, we can move. So similarly, we will move 0, 2, and up and down will be replicated. 0 to 1, 0. Down we cannot move, up and left we cannot move. So it means this is also visited. Okay. From 0 to where we can move. Now we are here. So we can move downward. This is the only possible case. So we can move downward. So that is 1, comma 2. If we are moving downward, it means downward current. We have not any did any downward operation, but we are allowed to do at most one operation. So it means we can go downward. We are going to this cell. So it means we are going to this cell. So this cell is also visited. Now we are at this cell. Okay, 1, comma 2. Can I move downward? No, I cannot move, right? Why? Because we are only allowing at most one downward operation and we have already took. So we cannot move downward. Okay, we cannot move downward. So this is the last visited cell that we have covered up. Can we move right? No, we cannot move left. We cannot move because this is an obstacle cell. Up we cannot move because it is already visited. So it means this is the only configuration that we can do by this. So the answer will be the 5. It means the 5 visited cells we have covered. So this is the basic example. But now let's consider we have a little bit more complex example, that is how we will why this approach will not work. I will going to show up that. Okay, so consider we have like consider we have given this another one example is take yeah, this example. So consider we have this example, okay, and consider we have given this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, and this is okay. Let me yeah. So consider this is the example we have given, and this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so till 7. This is 8 cross 8 example. Now consider we have given this starting cell is 4, comma 4. Okay, 0, 1, 2, 3, 4. This is the starting cell we have given. Okay, 0, 1, 2, 3, and 4, 6, 7. Yeah, this is the starting cell. From where you can go from this cell. Okay, let me little bit zoom it. Yeah. From this cell where you can go and consider upward direction we have given as 4 and downward direction at most you can took as 1. Okay. So like from this cell, first possibility is consider I'm going downward direction. Okay. I'm going downward direction. I will go left and I will go upward 1, 2, 3, 4. Till here I can maximum reach like this first row, right? So why? Because I'm considering like from any cell, I'm going to downward direction. I took all the left moves. I will go upward moves, and this is the maximum because down I took 1 and upward I already took 4. That is only allowed upward 4 and downward 1. So it means I can go to this first row, okay, and I can mark this visited all the cells, and I will give the answer. But what is the problem with this? Consider if you are not going to the downward direction, in place of that, if you are going first the right direction, then you move upward, upward, and from here you cannot consider we have cell somewhere here also, and you can move upward and you can move upward also, right? In place of downward, I'm going to upward 1, 2, 3, 4. So it means I can move further, right? Hope you will understand what I'm trying to say is from the fourth row. First possibility is I'm going downward. Okay, consider like in this example, like something like that. We have given something like this. Okay, and I'm somewhere here. Something understand like this. If I have allowed only upward 4 and downward 1, I can. There is one possibility is I can go downward first. Okay, I will go downward here, and from here, let's consider I'm going some left or right, and I will go 1, 2, 3, and I'm coming to here. So it means I have to upward 3 and downward 1 operation. But in place of that, can I do like something like that? One, two, and three. It means I can also go further. It means I can also go further if I'm not taking those downward operations. So it means, and this will give more visibility to the like all those empty cells. I can go over to those all empty cells. Okay. But in this case, what is the problem is if I mark this cell as a visited, if my I mark this downward and upward, all these marked cells as a visited, I will not go I will not be able to go further. Okay, because my upward and downward operations are reduced. I don't have any other options, and I will not be able to go any further. But in this example, can I go further right? Yes. Like if I will choose first go to right, and I will go upward, 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 I can go further also, right? So this is the use case that we are not handling in the current code. I've already written the current code for like Q1 that is uh, first I will explain why this current code is not working. Okay, that we have discussed in the first example. So I'm just simply making a one class that is considering row, column, up and down operations that you have to. And just like we are checking, first thing is the like the current row or column that we have given, that is the is the obstacle, and if it or it is not valid, then I'm just returning zero. And I'm creating one visited array to track, and just taking one counter variable, and like I'm adding this initial configuration RC00. It means we are on the current cell R and C, and we have not took any up and downward operation. And in this, I'm taking first thing is, and I'm taking the current row, current column, current up, and current down, and checking if the current cell is visited, like or not. If it is visited, then I'm just passing it. If it is not, then I'm marking it as true and incrementing our counter, because we have visited this cell, and this is an empty cell only. And now I'm checking in all the four direction. Consider checking up. So as I explained, if I am at the I comma j, for going to up, I have to reduce my row number one, and column number we need to keep the same. So first I'm checking is the new row and new column that we are going to consider is the valid or not. Valid means in the bound of the matrix or not. If these are in bound, so it means that we can go to that particular cell. For to going that, it means we are going to up. So I need to check the current up. Till now that I've already took the up. If I'm incrementing one more, is that operation is allowed or not? Like because at most you I can do. So is that operation is allowed or not? And is a new cell is the obstacle or not? So those things are confirmed, then I'm only going to that particular cell. Same for down, same for left, and same for right. For left and right, we don't need to check those extra conditions like up and down conditions. I'm just adding it up. And finally, we will return the counter that we have took. And this is the is valid function that is just checking like inbound of operations for the that particular row and column index are inbound or not. So this code will not work for this example, as I've said, like any example you can take, okay? Because that was a simple example. So in the example, consider the main problem here is we are not taking care of like in which direction first we are going. Either we are going to up or down or left or right. We have to maintain that like where we are going. Otherwise, what will happen is it will mark some cell as visited that that will be visited. But in the case if we marking some cell as visited, it will lose the visibility for the other cells that can go ahead. Okay, that can be possible answer. So to resolve this part, what we can do is the first thing is how we will solve this. Okay, so consider to particular part to solve this example is, and okay, so to solve this, okay. So first thing you need to understand is consider you have a matrix. Okay. So here we are facing one problem, like we don't know which direction we are going, and we need to maintain the upward and downward direction. So how we can solve this problem? Like consider you are at a particular consider this is zero, this is one, this is two, this is zero, this is one, this is two. Now you are at the this current row, and you want to go to consider this row. Okay, 2 comma 0. Now you are at 0 comma 0, and consider you want to go to 2 comma 0. Okay, for that it means row number for this is 2, row number for this is 0, column numbers are same, there is no point of that. So it means you are going to downward direction. It means you have to two downward moves. Any like you will first go to right or left and took downward operation, but you have to finally took two downward operations. Okay, so consider the in this case the final row will be my this one. So this minus this, it means two downward operations I have to. So it means can I write? like this is the consider my new row NR, and this is considered CR. This is my current row. So NR minus CR, it means these operations you have to, okay. And we have considered this as down minus up because I have took two downward operations and up operations are zero. Consider in the opposite direction, okay. Like this is 0, 1, 2, 0, 1, 2. This is 0, 1, 2, and you are at this point and you want to reach to this point, okay. So it means you are going upward direction. So consider in this way, like you are at 2 comma 0 and you are moving to 0 comma 0. So what it is saying is, it means this is the new row that we are moving. This is the current row that I am present at. So NR minus CR, what it is very value is saying, this is minus 2, and this will also equals to downward minus up. Why? Because downward operations I have not took, so it means 0, and upward operations I have took, that is 2. So 0 minus 2 is minus 2. It means the equation is downward minus upward is equal to NR minus CR. What about downward? So it means downward will be upward plus NR minus CR. This is the equation. So what is it saying? Consider if I have to decrease like where the problem is. Problem is like I'm going in any direction and I'm tracing those like I'm reducing my visibility to go further. Okay, so for that case, consider I want to reduce my upward moves. If I'm reducing my upward moves, this value will be the constant. So it means these downward moves will also reduce. So that is my possibility. Like what I need to do is I have to reduce the upward count. I have to reduce so that automatically my downward moves will also be reduced so that I will go further. I will go more cells to check like are these empty cells or not. If they will be empty cells, then we will consider them. So this is the only problem to understand here is in the current approach, the simple BFS, we are not going to consider in which direction we are going. We are just blindly checking, but in this optimized or like performance based, we will check like where we will going. Okay, where we will first we will need to make sure we are taking the less upward moves, less downward moves because we have a upper bar how many upward moves or downward moves you will take. So to tackle this, it means we have to taking something of like to take care of like upward moves and downward moves. So in first we will what we were doing is in that Q example, we were storing R comma C and upward moves and downward moves. Okay. So consider in place of simple Q, I will take some type of the priority queue. There I will store upward moves, downward moves, and the current row and current column so that I will have a clear visibility like where I will go. So priority queue will be handled like priority queue basically it will give you the priority number and it will give you the like mini heap. So basically less values for the upward and downward direction so that we will have a better visibility where we will go. Okay. So to for doing this, I have written that code for that particular. Yeah, this one. So but we it's just the same approach. In place of the queue, we are going to use the priority queue so that to tackle care of like where we are going. Okay, we have to reduce the upward count, and this is just a comparable. If you are comfortable with Java, you can refer this code. If you are not, you can take the approach as an example and you can write in your preferred language. But the main logic will be the same. Like this is just starting cell is blocked or not, and we are checking like visited. We are taking care of the initial cell as the up and down row and column, and we are marking this as a visited. We are just as it is move up, we are checking those conditions, and move down, we are checking again those conditions. Left and right, we don't need to take that extra condition like up and down in this, but we need to check like is that particular cell is empty cell or not, and visited or not, or like valid or not. So and finally we will just check like what are the number of visited cells that we have covered up in this approach, and finally we will return the answer. So this will give us the better visibility, like where you are going. So you need to understood one thing here is like you have to reduce the minimum upward or downward moves so that you can go better. Like you will go to explore multiple other empty cells that we have lost in the previous example. And why we have lost it? Because we are blindly checking and we are not going to be optimize. We are not checking based on the like where we are going. Okay. So hope you will understand this. So if you understood and learn something new, please like and subscribe my channel. Thank you, everyone.